So, our next keynote speaker is Helene Lidelöw from Sweden. And Helena is the CTO of Volumetric building companies. And before that, platform manager and R&D manager at Lindbäcks Bygg in Sweden. One of the absolute leading modular and industrialized construction companies in Sweden and I would say in Europe. She was also an assistant professor at Luleå Technical University, and that's where we first met, I think, 15 years ago. So we have since then collaborated in academia and then later also in industry. It's been a very fruitful collaboration, and I'm very, very happy to welcome you, Helena. There you are. I didn't see you. So I think this will be a very, very interesting presentation, and we will see how you almost physically could bring knowledge from Sweden and Europe over to the US and infuse what's going on around here. So very welcome, Helena.
Thank you. Thank you. Ladies and gentlemen, friends and colleagues, thank you for having me. Hej och välkomna till alla mina skandinaviska kollegor. Det är jätteroligt att ni är här. So I am very, very grateful to be here, and I will try to manage the double-click connection here. So if I do make an error, please forgive me. I have labeled this presentation Sweden-US 3-2. So it's Super Bowl coming up. So it's a bit of a game. So let's see if we can actually make sure that we understand that further slide down. But first, let me introduce where I come from, where I grew up, why this is important for what I do. So Sweden, very utilitarian, very sleek design, very simple stuff that we're doing. And the main thing is to serve everyone. This is a very basic prerequisite to do anything that has to do with industrialization, really. It's very easy to take that thought forward. It's a very strong industry culture, high number of patents per capita. We were recently actually named the most innovative country in the EU. I don't know how that compares to US, probably not at all, but still, everyone wants to lead competition. Very, very balanced approach to using natural resources. So sustainability, it's no surprise that Sweden is on the top of that list of countries who lead that charge. So when we look at what happens here, it was here. It was in the US that dimensional lumber and machine-made nails and anything combined with producing materials actually led to the introduction of the balloon frame. This was for US to expand to the West and actually create all the boom towns. So it's kind of the first industrial outburst that you saw here on the American continent. Now we came over to visit. My great-grandmother was born here in the US, and she moved and transitioned over with her family early 1900s. And like many, we have relations with the US. 1/3 of our population actually went here because we had a famine in the late 1800s. So in the 1920s, we brought back cookie cutter designs, and the first house factories were created in Sweden. Now you made the first modular home, 1929. That was here in the US. And it led to an industry that actually has developed manufactured homes, which is by some seen as second class, but to remember, they have actually housed a lot of people, and they never got any grants, they never got any support, they did it by themselves. We came back and looked at that and said, this is smart. We have a lot of sawmills, we have a lot of natural resource, let's build factories. So we started toying around with modular and panel factories as an elongation of our family-run businesses in sawmills. And now that became a very good platform for us to actually attempt solving the housing crisis in the 60s. Now here in the US, you had Operation Breakthrough, which was kind of an answer to the housing crisis that resulted after World War II. We had the Million Homes program, which was the same answer in the 60s. 1/3 of the Million Homes program was realized using technologies that you invented, which is the modular technologies, the panels, and everything that's wood structure. And we as in Sweden now, were able to produce 1 million homes in 10 years. That was something between the years of 65 and 75 to achieve that. Now, what did that result in for us as a culture? My parents were part of that. Our parents that are from this community were part of that. So we know what it's like to do industrialized construction because we grew up around it. And that's a super important factor for us now when we come into the second and even third generations of actually completing this. So when we move forward to what I then represent, I'm a structural engineer from the beginning. I started here, which is a particularly not very fancy 70s building in the northern part of Sweden. But I like to study. So I did FE analysis and software programming, CAD and BIM. This was in the 90s. So it was already kind of just bursting out. How do we use this technology? And it was super, super fun. So I stayed in academia, took a PhD, and then all of a sudden EU hit. So Europe is now beginning to become an entity, which is really, really also something that helps the market to grow. Sweden isn't larger than New England. So it means that our market is very limited. So if you want to do something at scale, you very quickly have to go outside the boundaries of the country. So here is where we met. Jerker alluded to this, and this is an industry-academia collaboration that I think would be very beneficial to this environment too. So we had, during 2006 up to 2013, we had 70 researchers and 24 companies come together and study what we here label as industrialized construction. That was all we did for these years. And it was really, really, really challenging because we never did it before. But it was a 3-part collaboration. So we had a grant from the state, we had a grant from the companies, and we had a grant from academia. And that's how we ran. So the results from this is a decade later, I can stand here and very proudly call many of these people my friends and colleagues. And if you read on their titles, you will understand that this is a network that's worth something. I have CEOs and CTOs in here. I have associate professors. I have everyone working on consultancy basis or in industry or in academia that I can call my network, that I can call friends and colleagues, and that will help if we need to move forward. So earlier today we had presentations saying, let's do it together, I would say this is a means to do it together. This is a way to actually make action happen here. So let's be theoretical for a moment, and several of you have seen this picture before, and I will try to put whatever was presented earlier today into some kind of context using that. If you want to ask questions later, that's all fine. If you want to ask questions now, that's actually all fine by me too, but I don't think the organizers might, approve of that. So let's go to my favorite pictures, which is the one I used all the time, every week actually. I use this to explain what happens in the industry. It's production strategy. So it tells us how far can you pre-engineer something. That's what's on the black box here. It also relates directly to your business strategy. So let's take people like the people who make configurators, Hypar. They thrive when they have standard products, when they have something they can predict. Same thing this morning where we had this fantastic building system that's automated by the architects. That's very cool. Still, they standardized a smaller part of it, so they now have pre-definition. And every machine works really well with pre-definition. They love that. So it's a really attractive portion to be in the production strategy at the bottom here for us who likes to automate, for us who like prediction. Right? What's the downfall with that? We never really discussed the market side of that equation, I think. And there is a risk associated with doing too much standardization. It is that you will end up with too small of a market segment, and then your company dies because you can now not bring in product. So when we operate number 3 and number 2, you have a market segment that's wider, but then you also have to juggle variation versus standardization. My message to you, I don't see the competition. Horizontal or vertical integration, I don't care. They can coexist. I'm fine. I represent vertical integration today. They are all needed because our enemy, if you want, is not ourselves. We shouldn't compete within this group. We should really work to change construction, period. And then there is space for every one of us. So the platform concept is something else that I worked with then here. This is what it is. And when I come into companies, they often say, yeah, we have a platform. Show it to me. All right, so where is it now? So it often ends up with being a digital copy of whatever product you're making, and that's it. It's a digital warehouse. Not to me, who has a more production-oriented outlook on this. I don't have any platform unless I understand how to make it, unless I have a supplier network, much like the one we heard this morning, and that it actually is integrated together. So when we worked through this together with Gustav here, who used to be my PhD student, thank you for doing that, he found methods to be able to bring this platform to life during our projects. And those are the ones that you really can rely on to make sure that your project and your platform meet, so you're not hindering yourself in standardization. So traditional construction and industrialized construction are very similar in the terms of we have the same process we need to go through. Now you look at the lower tier here, what's different is that now you can standardize parts of that process and organize that into something that you can reuse all the time. Reuse is good because it mitigates risks and it takes a profit to a higher margin because now you can capitalize on whatever you did before. So the first part is easy, where you have the configuration and when you have the ideas, when you have the digital space and the BIM models to help you. The second part is much unexplored. Where are the predefined processes that help us in the latter parts of production and also in the supply chain? So these, I think we're beginning to see that they actually can exist, and I think that's very important for the future. So after a few years, or rather 15 in academia, I had a big decision to make. Stay in academia, become a full professor. That was one option. And the second one was venture into industry and see if I could make this happen for real. And here I am in industry, so that's the decision. And as the little heritage from those years, we actually wrote a book together, which is absolutely only in Swedish. You can't read it. But it's fun. It's a secret. But it's good. And we use it in several educational programs back home. So it's very functional. We have dreamt several days to actually translate it. But hey, the authors are kind of busy people, so it's been hard, I would say. The house on the left is a modular building that was erected in 2015 in Sweden. So it's a 4-story over podium, and it's the Scandinavian design that I alluded to earlier. This is what it would look like, and you would never believe that it's a modular building, actually, from the look of it. So how can this work in reality? Let's go to something that's more industry-related. I was part of the team that started the Lindbäck's Super Factory. We labeled it in Piteå, which is a very northern small town in Sweden. It took us 3 years from decision to opening here. And we designed this factory to output one fully furnished, fully outfitted module every 30 minutes. So the factory was designed for 16 modules per day. And that was the entire driver for the design, was those 30 minutes of takt time. Every decision we made on automation, every decision we made on the workstation design, on how the workforce was going to be trained, was driven by those 30-minute takt time. So this is a one-piece flow. That's the second part that people are surprised about, because all the, as you see here in the picture on the far left, all the modules stand in one line. So the first question I get is, whatever do you do if something is wrong with one module? Well, you don't. You pre-plan, so you don't have those errors. And if you, for some reason, can't, there is a hospital bay at the end, like an escape. But only 3 places. So you're forced to do a really good prep job. And that really good prep job was something that I learned during this time. That was something that was really necessary. The CAM and the preparations for production, it's an underfed space in this industry, and it needs more attention than we have ever given it if we are to make this work. All right, we opened this factory in 2017 late. The first week we made 1 module. So that was not fun. Everyone was super frustrated around it. Then we started working to get this into something that actually could move the needle towards manufacturing. We organized all the working workstations. We had very good operational support in terms of line balancing and takt time, and then we started to do kitting and pre-assembly. So I've done plumbing trees, I've done harnesses, I've done pre-cut wood, I've done sheathing, I've done bathroom pods, kitchen kits, all of that jazz, to get this to run at 30 minutes. That was the entire target of this operation. So we created a whole company that made nothing else but bathroom pods to make this work. This was part of getting the super factory up and running, was to actually start a subsidiary. And they thrive today, and they sell to other modular manufacturers too. And those of you with the keen eye here will notice that this bathroom pod doesn't use any normal material. This is a glass fiber composite that you normally would find in a boat hull. So it's fully moisture proof, and it's also very light. So one of these is around 1 metric ton. So I can ship 6 of them on a normal truck bed. And of course, this factory has to do 1 every 30 minutes too. That's kind of the game, right? So the platform really came to life working here. We organized the components and the processes and the suppliers to really support this supply chain. If I were to buy a modular company, this is what I would look for. How much do you have in terms of IP? And this is not IP that's protected. There are no patents around this. But this is the knowledge that really runs the factory, really runs the company. This is what I would look for as an investor. I learned something else during this time, and now we're venturing towards the production part of the equation. The 4M method is when you combine the analysis of materials, machines, manpower, and method. And your normal resources are the 3 first: material, machine, manpower. The 4th one is the method to do it. And the method that we discussed here was the 1-piece single flow and so forth. And also, I learned a lot about the factory layout here and how important that is to succeed. So I worked with other suppliers on a consultancy basis in between all of this, and you would not dream of the many times I've heard things like, oh, we'll just move the floor over here and over to there. The move takes you 20 minutes. How are you going to complete that if you're also going to add materials and so forth? And that part of the equation seems to be very not explored. The first time I went to the US and visited a modular manufacturer here, an average one, I was super surprised. It was this much space in between the modules. They needed to bring in 2 forklifts to move the modular line at all, which took them more than an hour, maybe an hour and a half, to move the entire line. And my takt time of 30 minutes, it's done. Can't do it. So for this reason, we made a lot of studies here down to workstation level, where we actually looked at how does the product come in, what to lift it with, who's doing that, in what order. And that's where you get this to hum and run. So now I bragged about the planning. Let's talk about what actually happened then. We produced at 37 minutes takt time. And I think that was handsome for planning 30 and coming to 37. And then the market decided, I'm not going to give you as much, so we couldn't push. So we were sad about that. Our wall line team was nominated to the Lean Forum Prize, which isn't the Lean Construction Prize. This is across industries. We were nominated, and they were fiercely proud, and they should be. This factory attracted visitors from New Zealand, US, Canada, wherever you want, and to come and see whatever is it that you're doing. And we were very open. Never, ever did we deny anyone to come. We even had direct competition in the factory, and that was very helpful to us. That's how we created innovation within our space, is to have that influx. And we had digital tools for daily huddles. We have MES systems. There is visual planning, deviation reports, a whole set of digital tools to support the daily operations. And we had our suppliers working directly with us. So I was really proud of being part of this journey. And it was really rewarding to see that through. Now, there's another part that we can't ever forget, and that is that construction exists in a context. So we cannot, even if I wanted to innovate anything that I like, even if I wanted to build a factory that could do this in 15-minute takt time, doesn't matter if no one wants that product. So our production knowledge and intent must always work together with our market. So here's the easiest way to make an industrialized construction company die. That is to get it wrong. So you have a fully adaptable platform on your left and a fully standardized on your right. And your accessible market segment would be your dashed line here. So normally, your margin, overall construction, is just below that line. You have a margin of 7, 10, 12%. If you're good, 17 maybe, if you're awesome. If you operate a really standardized platform, your margin can go to 30, 40%, but only if you hit the optimum. And that's what this curve is telling you. Only if you hit the optimum. If you're going a little bit to the side and too far to the side, no, not going to work, because your biggest asset, your production, is not going to take it. And that's why, actually, we don't have so many that are fully standardized, because they don't dare. It's a risk on the manufacturing side. So they choose to have a little bit of variation somehow. There are the configurators, there are the different models, there are the different, all of that is there to take care of that. And of course, I mean, we could run super fast if we just wanted to make a box. One box, no windows, by the way, because that takes time. So this is the way that I've seen several companies now die, and the conversations that go on inside those companies. First of all, we have to take this project or we can't fill our factory. Many sales guys say this, and it needs to happen. Now, manufacturing, they answer, we can't manufacture this project. Design really has to understand that. And that's the conversation that happens also concurrently. And the last one is my favorite. Those sales guys doesn't have a clue. They sell whatever, and then we in the factory have to solve it. This is also true. So if you're now feeding your factory with a non-suitable project, you only have 2 choices. And those are the 2 axes we have here. You see the x-axis is the increasing the standardization in production. or on the y-axis, you increased your flexibility in the product. So either you have to decrease your flexibility, which means you can't take as large of a market segment, or you decrease your standardization in production, which means you're now sacrificing whatever productivity you have. Both are really bad because they will hurt you in the long run. You can do this for 1, 2, 3 projects if you have a good cash flow. You cannot do this for 10 because we don't have enough cash flow in our industry to sustain that. So this ecosystem that resides in Sweden here is an important point where I would really want to contribute the US to get to the same point. Since we've been at it from the 60s, we have machine suppliers that are local. We have software development. There is logistics expertise, and there is engineering that can handle industrialized construction. And the lower portion here, it's from a McKinsey report that shows that the off-site share of housing in the Nordic countries is somewhere around 45%, while US is 3, 4, 5% like this. Not to say that it's monetary the largest though, because your 3 to 5% is larger than everything we have. But it's the penetration ratio that drives this ecosystem. So, question then, can we bring this to the US context? Remains to be seen. I'm here now working at Volumetric Building Companies, which is a vertically integrated operation where we produce multifamily. Headquartered in Philadelphia, and we erected the largest modular structure on the East Coast. It was finished half a year ago. For those who are local, we operate the former Katerra facility in Tracy. We took that over mid-2021, and we have 2 factories more. There is one in Berwick and another one in Poland. So our Berwick facility would be what you find us at most of these factories. This is nothing uncommon. This is very manual. There isn't much to talk about in terms of driving the industry forward. It's a double-loaded corridor concept, which is something that still amazes me, that America chooses to produce really large chunks of modules. And they're bad to handle, they're very heavy, and when you ship them, they twist. So for me, it's like, well, why guys? Why are we here? I understand, because it is you can't do it. You can't transport oversized load unless it's one integral load. So that's a decision you made in the 60s, actually. So our factory in Tracy, we restructured this in 1 year. I started January 10, and then we already had the plans for how to make this a modular factory. We used machine suppliers that we know from before, and we are making panels first and assemble them into modules. I make them single modules, so they're not double loaded. They're half the size, and with ship loose or attached corridors to it. This was Katerra's factory layout. So when I first entered the shop floor here, it's so full of automation, so you can't really fit any material flow. If you see the orange color here, those are the only material racks in this facility. That's it. And for me, as being, I like flow, I like stuff that really works. This was inoperable. Can't run it this way. So we did this instead. There is a floor line, and a wall line, and a ceiling line. Those are the 4 vertical arrows that you see. And then there is an assembly line that goes across on the top. And anything that you see to the bottom right here, like 1/3 of the factory, that's material and kitting areas. So this is the restructure that's happening right now at Tracy. And of course, I want the materials to be part of that production flow. So I think material, and then I think pre-cutting, kitting, and then going into the assembly line. So now you're wondering, of course, how much is this design going to be able to output? Well, currently it's crawling. It's doing much of nothing because we're in the startup phase. But we have populated with the product and we are outputting. However, it is designed to do 10 modules per day. And this is where I want to go. So I know that it's diligent work and maybe 2 years from now, but I'm a stubborn person, as you understand, so that this will happen. So I have a movie clip that was taken last week from the factory. So if we could play. Thank you. This is the floor line. And we did something that I didn't think was going to be such a big thing. It's flipping over the floors, this operation, which I have people bringing up their iPhones and doing, taking a little snippet of this all the time. And the normal procedure here is actually for the US companies to hoist the entire module up and work from the underside, which for me is very backwards. So we flip it over and work from the right side of the element, and now bring it over to the assembly line. The Ottawa line here is kept from Katerra. This was running pretty badly when we came in. We needed to do 1,500 bug fixes because no one took care of the machine during Katerra days. Sealing line is new, and we infused that. This is 3 weeks old. We have a special thing that comes up here, which is you see, the panel is standing up, so now we can mud on the underside before it enters the module. Mudding is the largest enemy to making an assembly line really work, so you have to get that done. This is the main line, the assembly line, and the modules are lined up here in different stages of completion. And then I have 28 stations to complete, and I know that can be done. This is doable. Am I telling you that we're there now? No, I'm not. So there is a little disclaimer. But these are fully completed modules when they leave. We have sprinklers, electrical, plumbing. They're tested. Everything in terms of kitchens and bathrooms are done. So this is the first very good step for us to move forward towards, making this a real operation in the end. So let's talk. The final point I want to make is the digital information. I love digitalization. It's an awesome tool. I also love precision. So I like digitalization that gives me manufacturing precision. So we operate on Revit and BIM 360 in the A&E stages. There's a Dynamo script that creates the QTOs. And then we have infused a software, a CAM software, Vertex, to create the structural shops and the machine files, which is running the factory you just saw. There is full 3D coordination. I was brought up in Europe. Someone here said, we run our configurator or generator, yes, on IFC. Thank you. That's another thing you need to import here, because it's important to be interoperable when you're working in this industry. We have digital drawings on the shop floor, and there is a connection, back connection, to the ERP system, which in our case is SAP, to live attribute the costs that we have in production. So for me, this flow is equally important as the physical production flow. They can't really operate without each other. And I think that's a point that's important, at least for us when we're moving forward. So to sum up this, I want to say thank you, or the Swedish word is tack. And then also to infuse into you that I, as a former academician and as a former teacher, which I much enjoyed during those days, it's important to foster the coming generation. So do you have master thesis students, if you have PhD students, if you have visitors that want to come, those are most welcome, and we're very open to collaborate. The 2 pictures here are my children and also my granddaughter now, up to the right. So I do my very best to imprint in them how to function and work in this industry. So I succeeded with one because my son here is doing shop drawings and automation for industrialized construction. So thank you all. It was a pleasure being here.